Okay, so as time increases, what do you notice about the average rate of change? So between 0 to 1, 1 to 2, 2 to 3, 3 to 4. So just discussing, again, we're just kind of going over that whole idea of the slope of line. Larger negative, so it's getting faster. Describe what the average rate of change means in this situation. So look at the rate of change of the slopes of the secant lines as you move along the graph. So as you're moving along the graph, right? So again, it's going here, right? So it's heading up, and then it's turning around positive, it's turning around down negative, and it's getting faster, the secant line. So as you're following the curve, it's getting faster down. So this average rate of change is just looking at how fast it is moving, right? How fast it's moving. What is the average rate of change? It's how fast it's moving. This is the velocity. Okay, so you can use the word velocity of it, right? Velocity has direction. Speed is supposed to be just the speed which is not looking at direction. So velocity, so it's going from positive to negative, right? And that's how fast it's moving. So it's looking at how fast. So these tangent lines, these secant lines are looking at how fast. Does that make sense? So it's not, we're not looking at a really hard concept. It's just, that's all it's looking at. Determine the initial height. Okay, so these last questions here are bringing you back to a little bit of grade 10 work. So I just wanted to go over these words. So initial height, you might, again, like sometimes you look at this section and go, wait, is this, why are we doing this? I'm trying to bring back a few of the words, right? So initial height means at t equals 0, right? So in your brain you're going, initial is at t equals 0. T equals 0. And t equals 0, and we're just going to punch that into your original equation right here. Can you calculate in your head? Yeah, 120. I don't need to see that calculation either. Again, in grade 12, I'll let you skip some stuff right before it's like, show me the 0. Nope. Right, you put 0 in, it's 120. So yeah, read that from there. So initial height is 120. And make sure you put the units, meters. Meters, yeah, meters. Okay, so quick little sentence to answer, and I don't need to see you subbing 0 in. Okay, so initial height. The other word I want to go over here is determine the time that the rock hits the water or hits the ground. These are kind of similar questions. So rock hits the water, right? So when it hits the water, what is that telling you? It is telling you
the height is 0?
Yes, the height is 0. So h equals 0 again, right? Trying to refresh your memory. Right, h is 0, you don't need to write that part, but what I want to see is over here. Okay, put it all the way here on this side of the page. I did not leave enough room. This should have been a bit more space, so answer it here so we have a bit more room sideways. I'm just warning you because I ran out of room. That's my fault. I should have left more space, so let's move all the way over here. So then 0 goes into the left side of that initial equation. So again, we're still using the height equation, and we're putting it into the left side. So the height equals 0. And then you're putting it in here, so put it all the way at the left side of the page so we have more room, equals negative 5t squared, whoops, plus 10t plus 120. Okay, and we're going to solve that. You can solve it quadratic, factoring, up to you. This is factorable, so I'm going to factor out the negative 5. You get t squared minus 2t minus 24. I'm going to continue factoring. You can get rid of the negative 5. Right, because it equals 0. Right, because it equals 0, I can get rid of that. Divide both sides by 0, or negative 5, I mean. And then you're left with t minus 6 and t plus 4. Right, again, grade 10, hits the ground, set it equal to 0, solve. So then, therefore, t is 6 or negative 4. Now, when we asked you to cross it off, we should have asked you to say why, right? So some teachers made you state more, some teachers just said cross it off. Just cross this one off and you're going to say, okay, not possible or not negative. Okay? You don't have to do a full explanation, obviously, right? If they ask for more explanation, you can put more words, but I just want you to cross it off and say not possible or not negative, right? Time can't be negative, so that one's not a possible answer. Yep. Negative time. So when you're talking about the height of the ball, right, you're not over here. So we're not.
The negative 5.
Oh, the negative 5. Sorry, I thought you said the negative time. Negative 5. If you divide both sides by negative 5, That's a 0. Yeah, so you're allowed to do that because it equals 0. If it equals a number or something, you can't. Yeah, but 0 is a good number. You can divide it out. All right, so cross that off. Okay, so just cross that off so then you don't have to worry about that anymore. And then now, so this is what I didn't leave you enough room for, what is the rate? I forgot there's a second part to the question. So I want the rate at this time. Now, what we just talked about was we're doing secant lines, right? So secant line means I need 2 points to get the rate. So I need 2 points. But if I'm talking about 6, I don't have 2 points. So for now, we're going to create 2 points. So if I want the point at 6, but I don't have 2 points, I'm just going to take 2 numbers around 6, right? So a little bit before 6, so we're going to do 2 decimal places, so 5.99, and a little after 6 to fake it. So basically, I have a secant line, even though I want a tangent line. And this is where calculus developed. It went, okay, but I want a proper way to do the tangent line. Tangent means 1 point, which is 6. Without having to create a secant line every time. But for here, in advanced functions, we're going to look at the secant line, and then when we get to calculus, if you take that one, we look at, okay, what's the pattern that we found? Can we come up with a rule that we can use? And then they developed it into the tangent line. Okay, so tangent means a single point. For now, we don't have a single point method, so we're going to pretend and make this into 2 points. So a little before and a little after. Not too far. Like if I was saying 6, I'm not going to take, I'm going to take 0 and 20. No. So I want it really close to 6. So if this is 6, I'm going to take 2 little points beside 6. So let's do 2 decimal places. So we'll do 2 decimals around 6. Okay, so we're going to take 6, but we're going to do 2 decimals before and 2 decimal places after it. So it's very close. So we're trying to make it as close as possible for a secant line. I'm not going to take like 20 and -2 or something. Right around 6. So when I'm doing here, I'm going to do m equals my line. So I'm going to do h at, and I'm going to go 6.01 minus h at 5.99, or backwards. It doesn't matter as long as you're consistent with the bottom. Okay, so I'm choosing 2 points around 6. I'm going to do 2 decimal places. I always find that that works for all of our questions that we're doing. So 2 decimal places around. So 6.01 to 5.99. And then on the bottom, matching it, 6.01, the x value minus the x value. Okay. Plug that in. So take your calculator out and try to see if you can do it in one go. Okay, brackets where you need it, etc. So do the 6.01. So I want you to be able to get, you should get, okay, so take a minute now with your calculator. You should be able to get negative 0.5005. And then this one should be 0.4995. So please try that now and see if you can get those 2 numbers in one go. So we're doing this equation here, right? That equation there. So -5 times 6.01 squared. So a lot of the calculators, you can do it in one step. So 6.01 squared, and then plus 10 times 6.01 plus 120. See, I punch it all in one line and press equals, and I get that. You can show me the steps. It's just a lot of you go, yeah, I really don't want to write that now. Because look, you have to do it twice. And then this on the bottom, I get 0.02. Okay. Oh, and you'll notice, so look up just for a second. This is a terminating decimal, right? So you can see it was only the 4 decimal places. So don't round it. Don't round it to 0.5, because then guess what happens? That rounds to 0.5, and you end up canceling yourself out a lot, right? We need more decimal places. We keep as many as possible. We'll talk about that more next, right? Next time we do 2.2 or whatever it is. For today, we're going to try to keep as many as possible, so try to keep 4. Right? And then if it's terminating, keep everything that it gives you. So you can see this is terminating because it stops itself. So keep all of it. Like if there was 3, keep the 3. If there's 4, keep the 4.
Excuse the interruption, and good morning. It's Ms. Kurtz, your principal speaking. I'd like to take a moment, and I need everybody's attention.
Okay, so just write this, and I'll turn off the recording.
I do have some important reminders regarding yesterday's end-of-day school-wide emergency. As you are aware, just before the end of the day,